Have you ever wondered how physics affects a teenager's life? Well, we did, and we're going to document 2 average teenagers throughout their day and see how the laws of physics apply to their daily lives. Veronica is sleeping peacefully when all of a sudden her alarm clock goes off. Frustrated that her phone woke her up during her dream, she chucks the phone across the room. Veronica forgets to turn off her alarm and ends up throwing it while the alarm still sounds. In doing so, she hears the alarm changing in pitch and volume. For a second, she thinks she's dreaming again, but then remembers her physics and the Doppler effect. The Doppler effect is the shift in frequency and wavelength of waves which results from a source moving with respect to the medium. In this case, the source was the cell phone and the medium was Veronica's ear.
Julia is driving to school and she notices she's running 5 minutes late. Unfortunately, this semester, Julia didn't get a senior parking spot. Using the equation, speed equals distance over time, she can find out how much faster she needs to go in order to beat the juniors to the school parking lot. First, Julia knows that on a normal day it takes 10 minutes to get to school, and she lives about 5 miles away from campus. Second, we need to take the average time for Julia to get to school and subtract how late she was running to get a new time, which is 5 minutes. Third, we need to convert the new time, 5 minutes, into hours, which would be 0.083 hours. Finally, we need to plug in the known variables into the equation. Speed equals 5 miles over 0.083 hours. So she would have to be driving 60 miles per hour to make it to the school parking lot in time. With our calculations, Julia now needs to decide if she wants a parking ticket or a speeding ticket.
Veronica emerges from her car with her morning coffee and physics binder in hand. Walking across the front lawn, she misplaces her foot on a dirt patch and trips. Her coffee and binder go flying through the air. Let's figure out how long it would take the coffee and binder to hit the ground. We'll have to use the equation delta x equals 1/2 acceleration times time squared plus velocity initial times time. For simplicity reasons, we'll say that there was no initial velocity, so we can take that part out of the equation, and now we have delta x equals 1/2 acceleration times time squared. First, let's list the known variables. Veronica was holding the object 140 centimeters off the ground. The rate at which the gravity pulls objects towards the earth is negative 9.8 meters per second. We need to convert the 140 centimeters into meters. 140 centimeters times 1 meter divided by 100 centimeters equals 0.14 meters. Now we plug the known variables into the equation. So the coffee is negative 0.14 meters equals 1/2 times negative 9.8 meters per second times time squared. We can observe the coffee and binder hitting the ground at the same time. Let's see that again. Did everyone get that? Okay, good. Ignoring the fact that Veronica totally ate it on the front lawn, everyone can agree that the coffee and binder, varying in weight, hit the ground at the same time. This follows the law of gravity that everything falls at the same rate.
Julia returns home from school and immediately checks her Facebook. She's received a video link on her wall from her friend Veronica. She checks it out. Let's watch it with her. As we all saw, the biker in the video hysterically hits a wall. After a long day in physics, Julia can't help but wonder which one of Newton's laws applies in the biker's situation. She flips through her binder and finds all of Newton's laws of physics. Newton's first law is that every object in a state of uniform motion tends to remain in the state of motion unless an external force is applied to it. Newton's second law is the relationship between an object's mass, its acceleration, and the applied force is force equals mass times acceleration. Newton's third law is for every action there is an equal and opposite reaction. In the biker's case, both Newton's first and third laws apply. The biker remains in motion until hitting an external force, the wall, which stops the biker's motion immediately. The third law applies because the force at which the biker hits the wall is equal to that of the force that the wall applies back onto the biker.
Veronica starts her physics homework. She's working hard on a circular motion worksheet and comes across the equation acceleration equals velocity squared over radius. Veronica, being a tad bit bored and having nothing better to do other than her physics homework, decides to put this equation into action. She pushes back her chair and begins to spin. She feels a difference in her acceleration. When she puts her arms out, she slows down, and when she pulls them back in, she speeds up. Finding this very entertaining, she remembers her teacher saying, if she increases her mass, then she'll increase the difference in speed. She finds 2 bowls and begins to spin. Now it's more obvious that Veronica is experiencing a change in velocity. Teenagers are complex beings who use physics without even noticing. Whether it be tripping on the front lawn or checking their Facebooks, physics is being used every day in the average teenager's lives.